Okay, so today's is actually pretty short. In hindsight, I probably should have done A and B together, but that'll be okay. We're just easing you into the sequence and series. So 6B is called the general term of a number sequence. So yesterday was just looking at different number sequences, but today we're going to talk about the general term. Do you guys all have your step backs? So how many of you guys finished your assignment from yesterday already? Perfect. Then I don't know that you need to write this down, but this is what we've done so far. We've looked at lists of terms, assuming that the pattern continues indefinitely. And we also looked at number sequences described with words. So one thing you did was look at that list and come up with that description yourself. But you also had some problems like the very beginning that said, you know, start with 4 and then multiply by 3 or something like that. So we had like a verbal description or we had to identify the pattern ourselves. Well, what we're moving to today then is instead of a verbal description, we're going to use a formula to represent the general term, also known as the nth term. So that's kind of like the difference or the transition from yesterday to today. So instead of figuring out the pattern ourselves or reading that pattern described verbally, you're going to get a formula that represents what that pattern is. After today, we're going to get some different formulas for two different main types of sequences. But today, you're just going to kind of be given a formula for different types of sequences and use it. What do you guys think? So it's the general term, but we also call it the nth term. What does the nth term mean? So wait, what was that? Another variable? The number of the term that you're on. And so what number is n? Whatever number, so going back to a variable. So the general term means it could be any term. It could be the 10th term, the 2nd term, the 29th term, the 300th term. So it's like a general formula that can represent any term. Now, for n, it can only be a positive integer, but it can be any positive integer. So, you know, we've got the first number, the second number, the third number, the fourth number, and so on. And we're going with integers. Why does it have to be an integer? Any ideas? So like if I'm using my integers, I've got 1, 2, 3, 4. Why isn't 3.5 allowed? Like why can't we have 3.5?
Ugly and unattractive number.
That's debatable, so that's not quite the reason. What was that? Doesn't follow the pattern. Okay.
You're going to be using subscripts, so you can't put it.
It would look kind of funky down there. Well, think about it. If you're making a list, and I'm not talking about like an outline, but if you're making a list, you've got the first, second, third, fourth, fifth thing on the list. You don't really have like the thing that's 3.5 on your list, right? Yeah. So that's what I'm saying. I'm not talking about like some crazy outline. So it has to be an integer. No decimal points for n, or decimal numbers or fractions. And it has to be positive. We're not, you know, we start with the first term and then we keep going after that. We're not going back and having like negative term numbers in the past or some kind of weirdness there. So it has to be a positive integer. Now, if you see this big U with a little n, we would call that U sub n. So does that make sense with the subscript U sub n? So U sub n represents the sequence. So you're going to get, again, those formulas that represent that sequence or that general term. And we're going to work with those today. Are we ready? Okay. So the first example, we're going to consider this sequence. We're actually going to do two problems with this same sequence. So it's U sub n equals 4n minus 1. So that's our general term because what this one is going to do is it's going to allow us to figure out any term in that sequence. I could do the first, I could do the second, I could do the 300th, like I said, anything. And, you know, if I were to describe this in words, it would be something like start with -1 and you add 4 to it. But this is the way that formula looks like, so I don't have to kind of translate it and do it one by one and keep adding 4. I could pick whatever term number I want and then figure that out. So we're going to start with finding u sub 1. So u sub 1 is our first term. Where do you think this 1 goes? In the n spot, absolutely. So u sub 1 equals 4 times 1 minus 1. So then I've got 4 minus 1, which is 3. So u sub 1 equals 3. Keep in mind, this is the first term. Very good. So if I wanted to, I could plug in 2 and find the second term, and that kind of thinking will come in handy in the future. So good question, good observation. So we're going to use the same general term, the same sequence, 4n minus 1, but instead I want you guys to find u sub 10. So go ahead and evaluate that on your own. All right, how's this going? Anyone got it yet? What is it? 39. So any questions about that, or need to see that work? So what term is this? Good, very good. I just want you guys to make sure you understand that, because we're going to see this kind of notation a lot in the future, so I just want to make sure that you know that that is indeed the 10th term. So it's like the 10th number in this list. We're going to do one other type of example. Are we all good so far? All right. So this one, it says evaluate the first 4 terms in the sequence 2 times 5 to the nth power. So it doesn't say like a specific term, but it actually says the first 4 terms. So I'm going to have to use n is 1, 2, 3, and 4, and actually keep going with this math to get the first 4 terms in my number sequence. So I would start with 2 times 5 to the first power. So 2 times 5 is just 10. So that's my first term when I plugged in 1. Then I've got 2 times 5 to the second power. Keep in mind to follow like your order of operations. So I have to do 5 squared first, which is 25. And 2 times 25 is 50. So I want you guys to keep going. Find the third and fourth terms. Alright, what do we get for the third term? Good deal. What about the fourth term? Alright, so any questions about evaluating that or anything? Now, if you take a look at that sequence, this is not really quite a part of this section, but it's something you'll have to do in the future. Is this sequence like adding or multiplying to get to the next number? Multiplying, good. Now I feel that might feel like a silly question, but that's something you will have to do in the future is recognize if it's multiplying or adding to get to the next step or the next term. Alright, so the terminology and understanding the notation is really important in this section. So my stat box is a notation question just because I know what's coming. So what does, in your stat box, explain, what does U to the 20, or U sub 27 refer to? Use appropriate mathematical language in your description. Okay, the 27th term will be the 27th number in that list. No, I'm super short. I should have done A and B together, but whatever. Live and learn. Alright, so here is your assignment for 6B. Are there any questions from 6A that you want to go over as a group or any sequences that you're like, that was funky, we should take a look at?